Alright, today we'll be discussing how to perform an ANOVA analysis right here on our website. For this demonstration, I'll select a practical example that uses annual frequency data. Let's make sure we select the entire duration of the sample period, and then we'll define X as representing the level of investment intensity. Therefore, we have decided to designate the investment to asset ratio as an independent explanatory variable. And for our dependent Y variable, we're going to precisely measure the overall profitability. And we're going to be using, in this particular instance, the return on asset. So the question is, do firms with varying investment intensity have different levels of profitability? So at this point, we are simply measuring the differences between these various groups. So we really need one specific variable that we can use to define and form the groups, and then we also need the Y variable, which will simply measure the values across these different groups. And this, in essence, is the core idea that truly lies behind the ANOVA test. So I'll establish a 1-year gap for our analysis, which means the investment's performance is then measured exactly 1 year prior to when we can assess its full profitability. After we've completed that step, we'll be able to proceed by scrolling down to locate the specific ANOVA section. And in this particular section, we have the capability to incorporate as many as 5 distinct factors. To begin our analysis, we'll initiate the process with the one-way ANOVA. Subsequently, I will carefully choose the dependent variable, which we've identified as Y. Factor 1, which is essentially the primary splitting variable. First, I'll select a numerical variable from our dataset, which we'll use as the X variable. So I'll proceed by selecting this particular option, which represents the investment to asset ratio. And for our analysis, let's assume we want to create 3 distinct groups based on these investment to asset values. Therefore, each group has a similar number of observations, so we select this and then proceed with the ANOVA. So, naturally, we have a comparable number of observations. This result was entirely expected. We ensured an equal splitting. And then presented here, we have this table which clearly shows how the mean and other descriptive statistics change between the groups based on the investment to assets. The numbers you see here represent that investment to asset ratio. And of course, we would naturally expect it to be increasing because by its very nature, the overall investment amount will be higher when considering the higher level of investment group. Here, you can clearly observe the specific range of values, which allows you to easily identify that this particular segment represents the low investment, low G, or low factor group. We're looking at the higher and the highest levels of this factor. Here we have the ANOVA table displayed, and within this ANOVA table, we can see the p-value. This p-value is not statistically significant because its magnitude is greater than our chosen 5% significance level, meaning that if for example, if we were to repeat this experiment many times, it has been observed that groups with varying investment levels do not exhibit significant disparities in their profitability. Consequently, in this analysis, we are assessing 2 distinct aspects, namely the variation observed within each group and the variation that exists between these groups. The variation that we observe between the different groups is simply the difference in their average values or their means. Notice here that we have lower profitability with low investment, and it becomes progressively higher. So just by looking at it, we can observe that there's higher profitability associated with higher investment intensity. However, the p-value is not statistically significant. The reason for this is that we observe considerable variation within each group, which consequently diminishes the significant mean difference we might otherwise find between these groups. This reduction in statistical power occurs precisely when there is substantial internal variability within each individual group. So, the difference in these means doesn't actually mean anything significant statistically. However, if you choose to employ the median, a statistical measure often determined by the Mann-Whitney test, you'll find that the observed median differences are indeed statistically significant. This is primarily because the Mann-Whitney method inherently relies upon the rank order of data and is therefore considerably less susceptible to the influence of extreme outliers or to the natural variation that might exist within the different groups being compared. And that explains the reason why we have a significant median difference, but not a significant mean difference. So this particular analysis is specifically designed for a one-way ANOVA model. However, we have the flexibility to introduce an additional layer of complexity by moving towards a model that incorporates 2 distinct factors. For this expanded analysis, we should designate the second factor as a categorical variable, which means it will represent distinct groups or categories. As a concrete example for this categorical factor, let's choose something like sector to illustrate the concept. Though, in this particular scenario, what we're essentially asking is whether the observed variation in financial performance or profitability levels among various investment groups is primarily influenced by or contingent upon the specific industry sector they are operating within. So, in this particular situation, we are observing a significant interaction effect. Because of the presence of this important interaction, we can then proceed to include all the necessary pairwise interactions, and following that, we can run the ANOVA analysis. Okay, scrolling down here to the ANOVA table, it becomes evident that isolating factor 2 on its own is not generating any substantial value, which clearly suggests that the various sectors involved are not demonstrating considerable profit-making potential. And the specific industry sector itself does not inherently determine or significantly impact the overall level of profitability. The differences observed among the groups are quite significant, indicating that some sectors might indeed have a notable relationship between investment and profitability, while others clearly do not. This is not the case because sectors not even playing a role in the relationship between the first factor, the investment, and the profitability, as the interaction term here is also not significant. The final stage involved the Tukey analysis, which is specifically designed to function exclusively when you are dealing with a single independent variable or factor. Consequently, I will revert my approach and simplify the analysis by reducing it to just one primary factor, which is the investment itself. Following that adjustment, I will proceed to execute the Tukey test. And that will give you the pairwise differences among all of these distinct groups. For example, it will clearly show you the comparisons between the low group and the medium group, then between the low group and the high group, and finally the differences between the medium group and the high group, providing a full picture. These are all the possible pairwise connections that can be made, because we currently have only 3 distinct groups, and it will then tell us whether there's a difference between group 1 and group 2, or more generally between each and every pair. So, when we consider pair 1, it becomes quite clear that we don't actually have any significant value to report. We simply don't, and that's the conclusion. Instead, our analysis consistently fails to uncover any discernible profitability differences when examining groups that were specifically formed based on their investment intensity. So that concludes our detailed overview of ANOVA. Thank you all very much for listening.